So you want to register an AI agent with verifiable storage. You have probably seen the tutorials, the CLI commands, and the step-by-step walkthroughs. But before you start running the commands, it's worth understanding what's actually happening when you store an agent card with proofs. Because once you see the full flow, the individual pieces start making a lot more sense. Let's trace the journey from the moment you create an AI agent card to the point where it sits on Filecoin on-chain cloud with cryptographic receipts and an on-chain identity that anyone can verify. Everything starts with a JSON file. Your agent card is basically your agent's resume and business card in one document. It tells the world who your agent is, what it can do, how it can reach it to the masses. The format just follows the ERC-8004 specification, which means there's a standard structure that any system expecting to work with agents can parse and understand. Inside this JSON, you have got the basic names like name and description, but the most interesting part is the endpoint array. This is where you declare all the different ways other systems can connect to your agent. Maybe you are running an MCP server for tool integrations, or you have got an agent to agent endpoint for agent to agent communication, or you want to include wallet addresses across different chains. The spec is deliberately flexible here because agents do widely different things and the metadata needs to reflect that. You can also declare what trust mechanisms your agent supports, things like repetition feedback or validation through re-execution. This information would help other agents decide how much to trust you before they have ever interacted with you. So that's where we start a JSON file. Maybe a kilobyte or two of structured data that fully describes your agent's identity and capabilities. The question now is where that file actually lives, and that turns out to be a critical decision. You can store the agent card on chain because, like, even a small JSON file would cost real money to put on Ethereum or any L2 for that matter. And the ERC-8004 registry doesn't actually store your agent card anyway. It stores the pointer to your agent card. So wherever that pointer points needs to be reliable. If you use a regular web server, you have got a single point of failure. Server goes down, your agent identity breaks. If you use a traditional IPFS pinning service, you are trusting that service to keep your content around, and the pinning services drop content when like economies change or companies can just pivot. But Filecoin Pin solves this by connecting IPFS to Filecoin on-chain cloud. When you upload through Filecoin Pin, your file becomes accessible to the entire IPFS network, while simultaneously creating a storage arrangement on Filecoin, where providers have economic incentives to keep your data and prove they are doing so. So this is what makes it different from regular pinning services. So when you run the upload command, a few things happen in sequence. Your JSON file gets packed into a format that IPFS understands. The system builds what's called a binary Merkle tree from your content, basically taking every 32-byte chunk of your data, treating each as a leaf node, and hashing up to a single root value. That root becomes your content identifier, the CID value of your data. Because this CID is computed directly from your data, changing even a single character in the file would produce a completely different identifier. Content addressing gives you integrity, and that guarantee is backed right into the identifier itself. The same content that then gets submitted to the storage provider on Filecoin network, and in the Filecoin on-chain cloud, your file becomes part of what's called a dataset, a logical grouping of pieces that will be stored and proved by the provider. The data set gets registered on chain with all the relevant parameters which the provider is responsible for. How the payment work and when the proofs needs to happen is everything part of it. The upload returns several pieces of information, but the two that you really care about would be the root CID for IPFS retrieval and the dataset ID for checking your storage proofs later. So always remember these two values. The CID becomes your token URI for the on-chain registration. The dataset ID is your window to verifying that storage is actually happening. At this point, your agent card exists on a decentralized storage and is accessible through any IPFS gateway in the world. But it doesn't have an on-chain identity yet. That's the next piece. The on-chain registration is where ERC-8004 comes in. The identity registry is an ERC-721 contract, which means it follows the NFT standard. When you register an agent, you mint a new token, and where the token URI points to your agent card on IPFS. Your agent literally becomes an NFT with all the properties that implies. It can be owned, transferred, verified, and displayed in any wallet or marketplace that supports the standard. The registration transaction is pretty straightforward. You just call the register function with your IPFS URI, and the contract mints a new token assigned to your wallet. You get back an agent ID, which is just the token ID in ERC 721 terms, and that ID plus the ERC 8004 registry contract address becomes your agent's permanent global unique identifier. From this moment, anyone who wants to find your agent, query the registry, and can get your token URI, fetch your agent card from IPFS, and know exactly what they are dealing with. The on-chain record proves the identity exists and who controls it. The IPFS CID proves the content hasn't been tampered with at all. But we still need to verify the content is actually being stored, and that's where the proof system comes in. Once your data is on FOC, the storage provider doesn't just sit there holding your bytes and collecting the payments. They have to continuously prove they still have your data through protocol called proof of data possession. If the provider actually says has your data, they can compute the Merkle inclusion proof and submit it on chain. The PDP verifier contract would check that the proof corresponds to the expected Merkle root, and if the proof is valid, it gets recorded and the provider can receive payments through Filecoin Pin. If the proof is invalid or missing, the transaction would be reverted and the provider doesn't get paid for that period. This creates a tight loop where the only way to reliably earn is to actually store the data. Each successful proof round is what the Filecoin documentation calls a verifiable heartbeat. So do check out the Filecoin docs and you will find out the on-chain ongoing evidence that your data is set is still alive with the Filecoin on-chain cloud. So that's the complete picture. You got started with the JSON file describing your agent. That file got uploaded to Filecoin Pin, which made it accessible to IPFS while creating a dataset on Filecoin on-chain cloud with ongoing proof obligations. And then you registered on ERC-8004 identity registry, minting an NFT that points to your agent's IPFS card's location. And now storage providers are continuously proving that they hold your data with those proofs that can be verified on chain where anyone can audit them. Your agent now has a verifiable identity that doesn't depend on a single company staying in the business or keeping their promises. This on-chain registry proves that the identity exists. When another agent wants to interact with you, they can query the registry, follow the pointer to your agent card, and can verify the entire chain before they have even sent a single message to the AI agent. The practical walkthrough of this in the docs will show you exactly which commands to run and what output to expect. But right now, you understand what those commands are actually doing. And I'm sure that lots of ideation would be going on in your mind. So you're not just following a recipe, you know why the recipe works. So the agent identity with cryptographic like proofs and guarantees, and the whole flow takes just about 5 minutes once you have got your token set up. So what are you waiting for? Go and build something.